Okay, yes, class. So in the last class, we had to start with open organ pipes and closed organ pipes. So this much we had discussed that if it is open from one side and closed from one side, then the nth wavelength is 4L by N. And we had also discussed that frequency of nth is NV by 4L. And I have told you when it is open from both the sides, this is 2L by N. And when the frequency is from both the sides, this is NV by 2L. And N here, this also I mentioned that here N is all the integers. You didn't write it from here, all the integers. And here N is an odd integer. So in closed organ and open organ, we couldn't discuss it. So these are the things that follow. Now see, if it is open from both the ends, this is the initial equation, that is the incident one. A sine omega t minus kx. And yr is a sine minus, this is the reflected one. A sine omega t plus kx. So when you take this term, see a sine omega t plus kx, you'll have this term plus a sine omega t minus kx you will have. So you will add it. So what you will get? 2a, right? And then that will be cos kx sine omega t. I told you it's cos a sine b. So cos a sine b. So what would be the equation that you will receive? If I tell you the equation, it will be 2a cos kx sine omega t.
We are adding them.
Yes, what, Harsha?
Are we adding them?
Yes, we are adding. We are adding. This is an identity now, sine a plus b. So that's why we're getting cos kx sine omega t. And wavelength will still be 2L by N when we're talking. And what will be the frequency? Frequency will be NV by 2L. So this is for the frequency of nth mode. This is the speed of waves when we're talking. Note it down, then I'll discuss the rest of it.
What does L stand for?
Length of the string.
Okay.
Here pipe we will say.
This is for open boundary.
Yes, Harsha?
This is for open boundary.
Yes, 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 yes. Okay, one more formula we have. Gamma, which we had studied in the thermal unit, gamma P by rho is also one of the velocities formula that we use. This actually is known as Laplace correction. Laplace correction. Okay, here P is the pressure and rho is the density over here. All right, so here the frequency will be n by 2L because gamma P by rho because this is V. So V will use the value of P. But this will only come when gamma's value is given to you and specifically it has been mentioned. All right. Now, when we're talking about the first harmonic node, see lambda n what will become n when we're talking about the first harmonic or fundamental node? N is equal to 1. So this will be 2L by 1. So directly lambda is equal to 2L. And from here, we have to find out the length of the reflected wave, that is the total length of the pipe. It is lambda 1 by 2 because n is 1 over here. And what about the frequency? Gamma is Cp by Cv, this I've already told you. 1 by 2L is under root gamma P by rho. Then when we are talking about the second harmonic or the second overtone when we are talking about. First overtone is fixed. Second overtone when we are talking about the second overtone. One more thing. If I will draw it, no. If I'll draw this L by 2. This is only a half of wave as we have discussed earlier also. So here what we'll get, I've already told you these are points of nodes and antinodes. So that's why the last classes were very important. Now we just have to rush up with the values for open organ pipe. Now when we're talking about this, now same things we'll do for closed organ pipe also. See here lambda 1 will be n is equal to 2. So 2L divided by 2, 2 will be cancelled. So lambda 2 is equal to L. Similarly, frequency 2, not 1, sorry. Frequency 2 when we are calculating, this is 2L by 2L under root gamma P by rho. So frequency is actually double of the first frequency. This is the relation that is usually asked and that is very helpful in calculation of the rest of the questions. So this is how it will look like 1, 2 because it is open from both the ends. That's why we are drawing it. So these are nodes, this. And these points are antinodes. The points of maximum amplitude and minimum amplitude are nodes. Closed, I'll start. First, write these down. Then I'll start with closed.
Gamma is coefficient of volume expansion.
Yes, Harsha?
Gamma is coefficient of volume expansion.
No, gamma is the constant Cp over Cv. We had done this in thermal unit. Thermal physics also we had seen. Ratio of capacity constant. That's the same thing. Same thing. Cp over C, that gamma. This is not the coefficient of volumic expansion or what. This is that gamma. Let me just show you it. It's constant. Cp over C. This gamma that we had done in thermal unit. This gamma. Okay, Arsha?
Okay. Can you scroll up? Nano. Ma'am, was oscillations done before the chapter?
No, no oscillations is left.
Okay.
See, for closed organ pipe, this also we discussed that we have to subtract one. The formula is this. Just remember the formula. For standing wave, in the standing wave portion, we had discussed 2a sine kx cos omega t. This we had discussed right now also. The same formula came. So, lambda is equal to 4n, 2n minus 1, n is 2. Frequency I have not written. Frequency is 2n minus 1 by 4n. And after Laplace correction, this is gamma p by rho. Or best ways, you can write this as 2n minus 1 velocity by 4L. Sorry, not 2L. In closed organ pipe, this will be 4L. Please remember the formulas for all these. You get formula-based questions only from closed organ pipe. So these are the variables which I have written, which you have to remember in terms of all these. So when you're talking about the first frequency of the harmonic wave, it says with n is equal to 1 value. So this is 4L by 2n minus 1. And this is equal to 4L. When you're talking about the length, this is lambda by 4. So this is how it will look like because this is flows from one side. Second one, frequency is equal to 1 by 4L under root gamma p by rho. So frequency will be 4V by 4L. This is how it will look like. For second one, that is the first overtone. Put n is equal to 2, you get 4L by 3 and so on. Write it down from closed organ pipe, the formula first, then write the order.
Ma'am, it will be cos kx sine omega t, right?
Sine kx cos omega t.
Ma'am, in the previous one, we wrote
That
cos.
was open organ, no? This is closed organ. And we are talking about the standing waves in closed organ.
Okay.
basically this says that a pipe 30 centimeter long is open at both the ends. So which harmonic mode of pipe is resonantly excited by 1.1 kilohertz mode of pipe? Basically this is the frequency. So will resonance with the same source be observed if one pipe is closed? Speed of sound is, okay, one more thing, speed of sound you have to, in every question the speed of sound will be provided. All right. So when we are talking about open organ, firstly, when you're talking about open organ pipe, this frequency is equal to NV by 2L. So here N we do not know, okay, but velocity we know. This is 30 meter per second, right class? Length also we know, 30 centimeter a pipe long length of the string, that is the pipe. 30 into 10 to the power minus 2 meters. When we're talking about the frequency, it's also mentioned 1.1 into 10 to the power 3 hertz. Okay, n is missing. So we can calculate n, number of the harmonic motion that we can calculate. So if you substitute, this will be 1.1 into 10 to the power 3 is equal to n into 330 by 2 into 30 into 10 to the power minus 2. So from here, n will be equal to 1.1 into 10 to the power 3 into 2 into 30 into 10 to the power minus 2 divided by, this will be into 330. So this will be cancelled. This is 11. This 0 will come. 11 cancelled. So 2, right? This is 10, 10. They'll get cancelled. N is equal to 2. 2 means what? Second harmonic. 2 means nth value is 2, that is second harmonic. All right. So when we are talking about closed organ pipe, now we have the values for it. Frequency is equal to 2n minus 1 V by 4L. Frequency is 1.1 into 10 to the power 3, 2. Now we have the value of n. N is 2, right? So no, from here we'll first find out the value for n. This is closed organ. No, n is 2 for the open organ. So 2n minus 1, velocity is 330 by 4 into 30 into 10 to the power minus 2. So from here, rest of the calculations will be the same. It's just that we'll have 2n minus 1 is equal to 4, right? So n will be equal to, 2n is equal to 5. So n is equal to 2.5. It's not matching. It's not matching. That was 2. So it is saying, will resonance with the same source be observed if it is close? No. With the same thing, it's giving us n is equal to 2.5, which is not matching. All right. So this is how you had to solve this question. Write it down. All right. Just one thing I wanted to discuss regarding the extra class. Are you people available on Wednesday? Wednesday, 6:30 IST? Harsha, Siddhika?
Yes, ma'am.
All right, then I'll try to arrange your extra class on Wednesday. So we'll have 3 consecutive days also. Because this is almost on the end. This lesson is almost over. And kinetic theory also I have to start. Okay, we'll complete it then in the next class then. Let's meet on Tuesday. Then we'll meet on Wednesday. I'll talk about the extra class. All right, you can leave. Let's meet in the next class. Whatever doubts you have, you can ask. Okay, thank you so much.
Thank you, ma'am.